All right, everyone. So the second step after we have these scatter plots and just having a general description of what they are is to put a measure to it. So the way that we're going to do this is with something called the correlation coefficient, or the R value. So the R value in stats is a measure of the strength and direction of a linear relationship. So what that means is we're measuring how basically straight and together lines are. This doesn't work for curves, parabolas, anything like that. It has to be a 100% completely straight line. So basically what this is telling us is that if we have a really high R value, that it's going to be a perfectly straight line. And if we have a really low R value, it's going to be basically just random. So a few rules for R. It's between -1 and 1. It's going to exactly equal these things if it is literally a line. If it's like 0.999, that means that it's very close to a line. There might be a little bit of variance, but that's kind of the idea. So a few different things that we have to know. If we have points that are perfectly on a line, so all of these points are exactly on a line without any mistakes, variance, or errors, we would say R is 1. It is perfect, and it is positive because it goes up. Now, the flip side of this is that if we have, again, a line, we have some points on this line, and it's perfectly on the line, this would be R equals -1 because it is perfect, but it's also negative. So that is our perfect example. Next, if we have some points that go along a line and are really close together, this would be something like R equals 0.8. We call this strong. And again, it's positive, so it goes up. The same is true if we have some points that are, very close together. There's not much variance, but they're not perfectly on a line, something like that. Along these lines, again, it'd be the same thing, but negative. So we would call this, again, strong, and this time, negative. And you can probably guess kind of the further spread apart these points get, the less high the R value is. So if we start to see it like this, it's still an overall positive correlation, but it's not really all that perfect. Something like this would be like in the 0.5 range. There is a positive association, we'd call it maybe moderate. And that's the fun part about stats. You get to use all of these descriptive vocab words that honestly don't mean a whole lot. But the idea is it's not strong, it's also not super weak, it's kind of in the middle. And again, this one's going up. Other examples that you might see, just completely random. If you can't tell if it goes up, down, something in between, you're going to say that that is going to be pretty close to 0 and that there's no correlation. And honestly, anything from like 0.2 down is more or less random. If you can see something with 0.2, you're probably looking for it more than it exists. So once we kind of go below that 0.5, 0.4 line, it's not really as obvious. So don't be super exacting with these. I think a pretty common mistake is if people see like, oh, it's off the line, it's a 0.2. Like something like this, I think what people are going through, they would commonly say, it's not perfect, so I'm going to make it like a 0.5 or a 0.6. That's a pretty good line. They're pretty close to each other. There's not all that much variance. There's no outliers, things like that. So don't be a super harsh judge. If you can see a good relationship, there's not much variance, it's going to be pretty close to a high correlation coefficient or a high R value. So just a few notes there. Hopefully that will help you identify some of these things. So just be careful. Don't be too harsh of a critic, and make sure that value is somewhere between -1 and +1. The last kind of common mistake here that people make pretty frequently is with positives and negatives. So you can tell up top here, all of these go up. So this kind of green range here, all of these are going up. All of these lines, if we drew them, are going up towards the sky. That's why it's positive. The ones on the bottom here, these two are going down. So because of that, that's why they're negative. All right, so let's get some more practice in. Honestly, at this point, we're just going to be making some of our own scatter plots or evaluating scatter plots that we see and just judging them. Basically, I like to think of these on a scale of 1 to 10. How strong are they? If it's a 10 out of 10, that's your R value of 1. If it's like an 8 out of 10, it's pretty good but not perfect. We'll call that our 0.8 R value. So think about it like that as you're going.